In episode 5, season 3, we gave you a glimpse of working on a new battery monitoring setup for the boat. After that, we were asked to give a more detailed view of the electrical setup in Southern Promise. So this will be a technical episode. If you're not into the technical stuff, please refer to our other episodes where we share our experiences cruising in Scandinavia. In Southern Promise, we rely heavily on electrical power. We have no propane inside the boat. We have a portable Weber grill on deck. In case of any gas leak from that, it will drain overboard and cause no harm. We use 230 volt AC in our galley. We have a oven, a induction plate, we have a fridge, a dishwasher, a coffee maker, a machine for making for fizzing water. In the aft lazarette we have a freezer, and we have in the engine room we have a hot water tank that can either be heated by the port engine or by AC power. They are all, well, bar the hot water tank, they're all normal household appliances. Then we have 12 volt boat instruments that use power. We have a GPS compass, AIS, GPSs, wind instruments. They all run off 12 volt and they're all switched on all the time. Sources for replenishing electric power on board is either by shore power whenever we are docked in the marina, or our generator when we are at anchor. When at anchor, we do not want to run the generator all the time. On board are batteries, a large battery bank that will supply power whenever the generator is switched off. The inverters, we have 2 of them, converts the battery power to 230 volt AC to power the appliances on board. This way we can run the generator like a couple of hours a day to recharge the batteries and turn on the immersion heater in the hot water tank to reheat the hot water. Our battery bank consists of a total of 6 235 amp hour haze gel batteries, giving us a total of like almost 1500 amp hours, or 18 kilowatt hours if you prefer to measure in kilowatts. If we do not need to reheat the hot water tank, we regularly see we can run the boat at anchor from 1 to 3 days without kicking in the generator. It mostly depends on the chef, on food preparation, which appliance, how much each appliance is used during the day. As we are located in the temperate part of the globe, there is no need for air conditioning on board. In fact, there isn't any AC installed. In fact, we are for our winter cruising, we are more in need of heating in Southern Promise. For our inverters, battery monitoring, etc., we are all victron based. We have a victron isolation transformer that will isolate us from any ground faults in the marina we are hooked up to. We have 2 victron multiplus charger, a combined charger and inverters. They are each 3000 volt amps. They are ganged together, so behave like a 6000 volt amps unit. For battery monitoring, we are using the Victron Venus system. Being a computer geek, I did not use the original Victron Venus box, but instead decided to install the Victron system on a Raspberry Pi. Raspberry Pi is a small computer. It was originally designed and built for teaching kids how to program, but has since found many other uses. This is one of them. Like you can see, it's like a cigarette box. There's a processor. There's memory installed. Wi-Fi. It has USB connectors, and it even has a Ethernet connector. I'm upgrading our Raspberry Pi battery monitoring system now. I think this will be the third version of the battery monitoring I'm installing. The inverters have the capability to pull 400, 500 amps continuously from the batteries. If there are any bad connections within the DC system, the potential for heat and fire is really there. So the new system, new version 3 of the monitoring system, I will add temperature sensors within the junction boxes to keep track of any potential heat developing. We have decided to keep the battery monitoring and the charge monitoring in the galley. The galley is the place where the most power-hungry stuff will be controlled from. So for monitoring, we are using a pad that wirelessly connects to the Raspberry Pi running the Venus system to display status. Like we're pulling 215 watts from shore power, a freezer is running 70 watts being used, and we're drawing something like 120 watts for our 12 volt instruments right now. The system shows battery temperature and the temperature inside the Raspberry Pi itself. With the upgrade, I hope to add more temperature displays. I have one junction box for minus. I have one junction box for 12 volt ground. There is one junction box for the circuit breakers. There is one junction box for the main switches, and there is a electrical junction box for the 230 volt AC consumers. I hope to add temperature displays for each of those junction boxes. We are now in the lazarette under the forward part of the aft deck. From the right we have the main AC breaker panel, then the isolation transformer. To the left, the two inverters that transforms the 12 volt DC into 230 volt AC. Below we have three more boxes. This is the main DC breakers. They are motorized, controlled by a switch in the wheelhouse. To the left of that is the main DC fuses. We also have a smaller DC breaker distribution panel in the wheelhouse. To the far left were all minus from the batteries, and minus from the to the inverters, and to the distribution panel is connected. It's within this box that I have mounted the Venus system. Let's have a look at that. This is what it looks like inside the ground or minus connections. This is where the ground for the battery banks connect. They connect to the shunt, a bus bar connecting all the inverters, and a connection to a 12-volt distribution panel up in the wheelhouse. In my previous setup, I had the Venus sitting here connected with Velcro. I have decided to move it all into the door of this box. So inside this box is the Raspberry Pi I showed you earlier on, running the Venus system, the battery monitoring connected to the shunt, measuring current in and out, measuring battery voltage, and this connects into the Venus. The adapter for the inverters, measuring AC in and out, DC out from the chargers. Over here is a DC 12 volt to 5 volt power supply. The Raspberry Pi is running on 5 volt USB. And finally, what's really new in this version is this set of terminal blocks here that connects the temperature sensors. So this is the yellow one is for data. This one is 3.3 volt for the sensor. This is ground for the sensors. The terminal block, well, each terminal block is 4 centimeters. So that will be 4, 8, 12 for the length of the terminal block. Then I'll add another 4 centimeters like this, and I'll remove the outer jacket. Like this. So the yellow is to be the longest, the red one is next, and then the black one like this, and then the black one. Next up is crimping on these tiny connectors. Like this. Then the lead. And then crimp. Ooh. Mount the connector, insert the lead, crimp, that's it. Pre-bend, makes it easier to insert into the crimping tool, like this. Crimp. So next is add a plastic holder to the connector. Like this. This is what the Venus display looked like prior to installing the temperature probes. Currently on the bottom there's a battery temperature and the temperature of the computer running the Venus system. While I'm having this box open, I will also check that all the connections are nice and tight. Loose nuts, loose bolts, making poor connections is the main source of heat and possibly fire. So I'll use this opportunity to check that all bolts, all nuts are securely fastened. That should be all. They're all nice and tight now. So it's about time to close this now. All the sensors are connected to the terminal box. I'll tidy up some more of the cables and then put the lid back on the box and go inside and see if we can see the temperature readings on the Venus display. Aye, it works. It was all worth the effort. From the left, there's a Raspberry Pi processor temperature. This is the 230 volt AC box, the minus or ground, the 12 volt fuses, and the 12 volt main switches. Right now, it's as I just started the system, it's about 15 degrees Celsius, so it's not showing real operating temperature. When the system is running, the temperature will probably rise somewhat. As long as you can touch a component without burning yourself, it's okay. If you have to pull back immediately because your fingers get burned, it's too hot. Right now, it's okay. Another use for the pad is to control the hot water tanks on board. So the Promise has two hot water tanks. One on starboard side, it's heated by an immersion heater. The port one have an immersion heater and is heated whenever the port engine is running. I have programmed a small computer, an ESP8266, to connect to the Wi-Fi network on board. I have programmed it to be able to switch on the immersion heater on the hot water tank. You can see it on the Venus displays. It's now pulling, instead of just a little bit over 100 watts, it's now pulling 2 kilowatts. So I'll switch it off again. It also controls valves, so we can decide which tank to pull hot water from. The left one, the port, both has an immersion heater and it is heated whenever the port engine is running. The right one only has an immersion heater, so the only way to heat it is by electric power. So we can individually switch on and off the immersion heaters, and we can control the valves out of the tank to control which tank we pull hot water from.